Good morning. No, wrong window. Or whatever it is, wherever you are. What I'm noticing so far is we have a lot of, like, sharper edges on here. Oop, this doesn't work well. We're still assuming it's full screen. Oh, okay, well, that's the conch shell. That's not unexpected. There's some bright pixels down here. Oh, well, that's the lock. So it is showing up as brighter, though. Hmm. One thing that I did with the map was I basically did a canvas that was twice the size and then scaled it down. That might be a thing to think about. It also won't be as small once we get everything worked out here. But yeah, the canvas version right now actually looks worse. The problem is when SVG looks really worse. Alright, so short of doing that, I think we're on to the lines. And I guess I don't need the circle now either. It's not view. That's going to be in canvas. It's probably one of our first circles. Or not. Oh, you know, that's a fill. So that must be my center point. Okay, so that's you. And of course it's the first item. Oh, right, we can actually count it out. Oop, I didn't actually want to have that full screen. So boons. This is in reverse. No, this is in top on top order. Right, we actually did these around. So this one actually seems like a simpler start, although it's going to hit most of the code. All right, so you were done below. So we have the icons on top of the gods. So the gods are on the bottom right now. This is below that. Oh, and we're not going to be stacking. That might be grouping. Oh, no, this is list.concat, so these are all returning lists, so that's fine. And you're probably going to get into the whole mess of sub-functions. Oh. Now you see, this is doing... Yeah, that's where we got into a bunch of point stuff. Okay, so there's duodash. Although maybe that method's going to be completely different if we even have dashed lines here. And we were putting this roughly where? After display boon trait. Okay, so image was a helper for that. Okay, you were going to return a renderable. All right, so our other library had line styles. Let's see, is this engaging library methods here? Kinda, yeah. If this isn't supported in the Canvas library, that could be an interesting situation. Shoot, can I? Well, you're just saying traced in line style. All right, so you are doing, there's something called group here? Group A, group B. So draw nothing. How do we do arcs? Okay, so you've got your own arc. Okay, we potentially have complex paths. There's the Bezier curve 2. Line 2, move 2, quadratic curve 2. So arc is a center, an end, and a midpoint, which for duo arcs, we actually kind of care about those are actually are two separate things. Start angle, end angle. I guess I could get back to that. Or is this actually in that? This is cubic curve. So this is using the Bezier curve thing. The funny thing is, I probably interpreted this from something that's closer to this style of arc. Okay, you're gonna be mad. Now this is Boon chart. Oh, maybe it's specifically duos that deal with that? Because this is all kind of in the same terms. Duo archetype. So the midpoint is kind of a thing there. Oh, you know what? Actually, I'm not really using that anymore. Because I think I figure out the position of the icon. All right, where do we create a duo arc from? Oh, this is doing a lot of point calculations. Okay, so I'm calculating this from first principles, so it's not necessarily going to deal directly with angles. Although maybe these are angles? No, we're not doing any rotates here. To support both of these, I was kind of hoping to get away from all the visor curve stuff, but I guess I still need it to an extent. For the elliptic curves, which are not represented here. Okay, so that's going to be the radius of the circle we're doing. And A and B midpoint. Maybe duo isn't the place to start. Of course, the other arcs are going to have to deal with elliptics. Which is still going to require some visor stuff. Alright, so converting this back into that form is actually going to be possibly more trouble than this. Now, cubic curve is actually the function we had in that library. Okay, so this is part of paths. So you would have to do like a move to visor curve 2. Which, interestingly enough, we kind of have that when we do this stuff. Just stick them together. That's a boon connector. This is like duo connector. Yeah. That's a cubic curve that relies on curve points, which is the function we found. And the curve points from angles. Well, hopefully, if we have angles, we can just take that over. So this is like kind of going the other way on it. So you were duo dash, which was right below that, which we don't know if we can do yet. Curve points from elliptic. Do you have a type? You do have pet type for this. Mandatory to pass the starting point. Implicit move to. Okay. So actually we don't kind of need to do that. Now we had this join thing. But that's from angles, so we don't need that. For elliptic arcs, well, this is the same thing where we have to split large angles, but elliptic isn't supported by this library, so we do have to kind of do that. Yes, I was calculating all of the points. So this API actually ends up being very inconvenient. Okay. Can I break this out here? Oh, but you're a point in a list of path segments. Hmm. So we're going to get a list of points. I mean, do we have to change what this returns to be a start point to a path segment? So this is not from, well, the thing we want to pass it is a list of points. Uh, So this was a cubic curve. So if we use the same preparation, then the next couple of points would be in sets of threes. Kind of seems like we have to rethink this. What are we working with? Arc from points actually creates us a path object. What are we creating? We are creating trace turns it into a renderable. Path turns this into a shape. So those could technically be in the same line style. Do we punt on this? Do the lines? Because a line should be easy, right? Right. Okay, so that's still a kind of path. So this is going to be a single... Oh, it has to be at least two shapes, because we have different styles. Actually, you're a list. Which is redundant until we actually do those separate styles. Let's see, so these are going to be individually lists. Could I just have you return a list? And we can cat it all? That would be one way to handle it. So you're mapping, so you actually need to be... Can cat map? And arguably that could possibly work for these as well. Alright, so we're still got a lot of stuff going on. Oh, we left this completely empty. And this stuff was like half... Yeah, I don't even know what to do with you. Oh, we did decide to do this. Did I alias this? Yes, I did. So you see, shape wasn't a bad word when I set this up. Oh no, it's shapes anyway. Not that I like ever do it with multiple shapes, because they only have different settings. Okay, we can not yet draw lines. Now, I might have not given it a line color. That could be the issue. And the line thickness. Pattern thickness color. So do we even have these options? There's going to be a settings dot line, line width, line cap, line join, line dash, list float. Hey, at least it's float this time. Line dash offset, which I basically handle by using alternate patterns for the two things. So this one is just a list of floats. Is odd. The elements of the list gets copied and concatenated. Interesting strategy. Alternately draw a line and its gap in coordinate space units. So and we already kind of worked out the offset by this. Although I guess the offset would be a better way to do it. That would mean returning a list of settings. Which if that's the only settings we need here, that's fine. I mean, or we just depend lists. Or we return just the list float for the dash. Oh, you know what? We need line thickness anyway. So it's going to be like three things. Oh, and stroke color. Da, 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 da. We do in fact set these both in on one condition. Is that the same as that? It's not line dash, just line width. But then pattern I don't think we need. Oh, but this depends on... Oh, this is still your color things. I guess I could actually say, just gotta set stroke there or something. Yeah, it's not line dash width. Line width. No, I don't actually call you. Okay, error consequent. Okay. Ooh. Okay, so we've got some inversion to do here. Okay, and that's the gray line being drawn over it. So maybe our units are different? Oh, I guess this could be a Y flip. Let's see, do I pull these out any particular place? No. Okay, that fixes that. What the heck do I have to do with my dashes here? Oh, wait, I was doing a 0? Oh, but we were doing 2, so it's really point 1 point, or it's really this. The zeros was to change the offset. Okay, that is indeed positioned a little bit different. I mean, not that this part really matters. It's just interesting. That's comparable. Okay, so that takes care of the dash patterns and the straight lines. We're going to have to flip all of our points, apparently. Which is kind of weird, because I almost feel like I would have prepared... Well, I probably prepared things for the SVG coordinate system. And I was flipping certain points that were coming in from the outside, like the screen offset. All right, so this thing is going to give us... That did cubic curve. Cubic curve is a path which requires us to use a specific thing that takes a specific number of arguments. So I used to be able to use cubic curve to just take a list of points. And we are kind of like joining this twice here. They do overlap on one point. But I also have to calculate my control points. I could rewrite my arc from points to return path segments. Or maybe it would be just as easy to have it calculate the angles and call arc. As an arc to the path with the given control points. Never elliptical. So we're still going to be dealing with curve stuff for that. Yep. So that would be point. Well, I mean, really, we could just go to arc B at that point. and a well, path, yes. Arc to the path with the given control points and radius. To the first control point. Arc is tangential to both segments. Okay, so I don't think this is actually going to be the number that we have. Okay, yeah. I'm not sure if this is part of the Textile Black. Move to Arc 2. So you draw up to there and then go as far as that. So that would still involve calculating one control point effectively. That is not what we have. Wait. Oh, does this not even have... No, this... Oh, no, there is a shape that's an arc that has angles. So the curves we did before involved some tangent points, which I don't know if those are actually would fit that Arc 2 model at all. So you were giving me a shape. Path gives me a shape which has to be put into shapes. Curve points gives me 4 points. If we use this only for that, which I'm not sure that actually types out because it just says a list. It doesn't actually say the rest of that'll work. It might also work to flip stuff going into this. But this is where it goes to the library. Okay, so this is actually up there that it's having trouble. Right. Well, you're returning cubic curves, so you're basically returning shape. Path. List of path segment. Includes empty list. Right, so we can't do this in the argument section here. Which kind of says that we should be passing around something better. Now, it just so happens that our first point is one of these points, so you could reconstruct the first point needed to get past there. So we could have this return a path segment. At the moment, I'm kind of copy-pasting these functions around. Maybe there would be room to extract them, but now our formats are a little bit off. Or rather, we can't just do just return an appropriate thing. Now it says it has to return a shape. Oops. I would actually, call this. So what do you need to do? Oh, I can actually do this compression a little bit here. Nope. Start over here. Alrighty then. I kind of want to see how this works out on on all this stuff. Before we go changing it around. so there's display duo connector, display boon connector. That ended up display boon trait. Image. Oh, no, okay, so first of all this. Okay, so duo connectors on the other side of display gods. Oh, you're a map too. So we can't just throw the concat map in there. All right, so that was the thing that was right after display boon trait. Will you make sense to return a list? Well, some of these might be groups. I guess boundary is going to kind of be a group. But it's all going to be stuff that's displayed the same, so it might actually make more sense not to be. Except for the no-op case. Okay, does that need to be uniform? You see, that's a complete line style. Which I guess line style would end up being... line width, stroke. All right, so all of these are going to be... Oh, now we have to have a dummy as we build these out. And we added so many types of paths. Oh, did I have a local group here again? Yeah. Not even syntactically correct. Maybe I do need to do a list of list. Okay, we've not rendered anything yet. All right, so line's going to be the easiest, right? Okay, well, it fills in a bunch of stuff. This feels so much brighter over here. I presume it has to do with the way it handles the pixel blurring as you go down. Well, and then there's always SVG blurring. Yeah, this like blurs the entire thing. This like subsamples the image. Okay, so that's an easy one. This is so path before took just a bunch of points. This is it's just map line 2, I guess. But we have to care about the first one. So this is something we expect to show up like in Aphrodite. Okay. So an elliptical arc is going to be a big problem. Let's see, so circle actually took a center here, didn't it? Okay, yep, center and radius. And we expect to see that in Athena, at least. Let's see, so boundary, yeah, there's arcs again. Now this is from angles. So this would translate better to the canvas path version. And also angles. So I guess we should work out basic arcs here first. This is a singular arc, so we need to know, what do we have? Center radius from angle to angle winding. Let's see, so we're, no, this particular form, and I don't know if this particular form has a path version. I guess that's a slightly different constraint than the angle version, but we're gonna have to figure out how the conversion works. I'm actually wondering if I converted from a path-like form in the boundaries. So that means I'm not going to really be able to use a sub-function here. Or rather, it's not going to be, you're not going to get a great amount of reuse out of it. I wonder if I could apply an inverse transformation on text to fix its flipping issue. And I could just flip the coordinate system of the entire canvas. All right, so you want radius, and then I did from to, they did start end, and they have a bool for clockwise. let's see, so this is saying clockwise, so if arcinfo.winding, I could just say equals clockwise. Okay, there's a few things wrong there. It looks like maybe our from and to is... Either our from and to is messed up, or our clockwise is messed up. Could you continue zooming, please? No, that doesn't seem right. Oh, these are probably absolute angles, aren't they? But even that doesn't entirely make sense. Oh man, we've got some like stuff from Artemis that's just all over the place here. What the heck? No, yeah, this stuff is still totally bonkers. Okay, well, that's a circle. I wonder if we have a different circle origin point. I mean, still, our locations are just weird. Do we not flip this one? Well... Yeah, that's like... I'd say that's worse. Granted, I never looked at some of these spots. We know paths were kind of working, so maybe I just have to do this in path form. There's just so many I have trouble tracking what's even supposed to be what. So we can kind of guess this one is supposed to be that thing. So in that case, it's just... It's like the angles are reversed. Start angle, end angle. Oh yes, it is reversed. So what do? We do just tau minus r? Oh, wait a minute. These rotates worked out okay. Oh, did I do rotate negative? Oh, I guess that works too, huh? That looks better, but once again, that calls into question all of our coordinate system stuff. All right, boundaries. Only deals with basic arcs and lines. Although we do have to deal with some path stuff now. And that is from angles, but the path form of arcs doesn't deal with angles. And that's really just a trivialization of the curve. So we don't need to deal with curve points for that because we're not using that as a universal path abstraction. Curve points from angles. That uses the join, which we don't. All right, so if we're doing cubic curves, because we don't currently have the math to do this. Oh, and look, we're back to a y-inverse coordinate system. So the join is not going to make sense here. So the more immediate version of this is to change our things to return paths. And then maybe at some point we have to see if we can rejoin some of that math. So you get used once. Cubic curve gets used so far once. So you were just a wrapper to get that point around there. So we kind of want to say Oh, wait, you were handling the flipping. Well, that was all negatives, right? Actually, this way kind of take over arc from points. There's a little loss of generality here. Ooh. Right. We actually want to do the Barzier curve section of this. And the things that call it. Can reuse the target point. All right, so that leaves this as a thing we can reuse in that context. Ew. Our start point depends on what we get first. Ooh, and you're from angles, so we don't even have the start point. Ew. So we did the arc thing, assuming that, well, there's this curve points from angles thing that we don't have right now. This is all going into a cubic curve, but that is a way to get a arc into there. We have no other way to get an arc into there. Do I have to return a point from all of these and throw it out in most cases? Also, are we interpreting... This would be more of a decoder thing, wouldn't it? No, you've got both. You've got both units. It's fully encoded. So both of those, we're going to have a function for lines and a function for arcs. They both need to return their origin point so that we take the first one, pull off the origin point, and then go down everything else and throw out the point we generated. Which I guess is kind of what the join curve points was doing. We were just kind of doing it, yeah. That's basically what we're doing there. Or maybe we, if the function, well, so the line is trivial. For this, I guess we could just have a start point of arc. It's a little weird because you kind of have to calculate this entire thing anyway. Well, wait a minute. No, we have a start angle versus a from angle. So that has been transformed a little bit. Yeah, this gets hairy enough. I really don't want to duplicate it to have like a start point of arc function. which means that you're returning a pair. Boundary line basically just is a pair, except that in some cases you want to convert it into a line 2. Well, that was a trivial function to begin with. And I guess I could do the flipping. Of course, what if the first thing of this is an arc and we don't implement arc right away? I wonder if I can cheese this a bit. So this was curve points. It is going to be like path for line. And what are you for now? I guess a see, is line 2 relative or absolute? It might be absolute. In which case there is no op. Let's get moved to center. Of course, all this has to be flipped. That's basically what that is. Okay. That gives us a list of those. We need to... Well, we have to then guarantee that there's actually something there. This might be a let. Rather than a pipeline. Caps lock. I guess we could do a null path. No, path is only a shape. We have to do shapes, line style. Actually, areas can be filled. Oh no, okay, so that's boundaries. This is path segments. Local group again. Okay, that got us Zippo. And maybe we got some weird stuff going on with there. So what did we decode? Okay, coordinate, line 2, line 2, line 2, move 2, move 2, move 2. Well, we definitely got something. Did we end up overflipping? I don't see it over here. I don't see it over here. Did we take that path? Yeah. Draw op fill. Oh goodness. Yeah, that's wrong. So nothing out there. Does it not count as properly closed? Okay, so I guess that must be these must be basic settings. Yeah, fill, stroke. Huh. Well, if it's a fill issue, we should be able to draw it like any other line. Okay, so there's definitely something there. Oh, you know what? It probably isn't closed because maybe we finished on an arc. To do that, I guess what we do. Now, once we add the arcs, it should actually be able to close. But we could always do a line to the start point. That's going to be an append. So it gets a little bit ugly. Okay. Why don't you like that? Oh, you're a singular. Yeah. Actually, that doesn't look closed. Maybe this needs to be line 2 for my interim stuff. Okay, that might help. Maybe I don't even need that last thing if I get that right. Okay, so that did something. Now, can we get by without you? Yes, we can. I'm kind of surprised we don't have this bend. Because these should have just been straight up lines. Actually, even those arcs aren't great all of a sudden. I almost feel like something went wrong while I wasn't looking. Uh-oh, did we multiply by 0? All right, well, we've got to fix this. So that definitely got a little bit hairier. Yeah, there's an easy way to flow that. All right, so we had arc from angles, which comes down to curve points from angles. It became curve path. Okay, archetype to list point. So this is going to be, oh, this is actually a list of segments. Because you might have two pieces. Oh, so you were actually calling to curve points. All right, so we translate this into units that we can use to do this. Curve points. I see curve points became curve path, which gives us a path segment and no point. But it has the endpoint, so that's actually maybe okay? Syntactically valid. And this is not what we called it. Oh god. That angle. Path from angles. I retyped that from scratch, didn't angle makes sense. Well, that's actually exactly as bad as it was before. How did I not notice this before? So I don't know what the heck is up with this corner in here. I wonder if that's the beginning or the end. Can I tell what the point order of that is? No indication of which one is the start point. It's like I kind of don't want to have to deal with interpreting coordinates, but I'm going to have to do that. Now it's based on that polyline. Now is that because of where I selected it? No, okay, so this tells me that this must be the start end point because it's colored different. And interestingly enough, that's kind of what we skip. So like these must be like midpoint, or it's like select that line, and then these are terminal points. So why are we skipping? Oh, because I'm actually skipping one element. So we do this, we have to get the first point out of U. You know what, we should go back to segments for this, not rest. So actually, I don't care what this is, I just need the first one. All right, and then the problems we have here are actually problems with some of my curve calculations, apparently. Because we're getting exactly the same result. Is that an artifact of... Oh, this is an artifact of the rotation. And it's an artifact of rotation in both versions. So it is an error in how we're dealing with that. It's interesting that it's mostly right. Okay, so at another orthogonal position, it's fine. I guess these only put you at diagonals. Oh, okay, so we found a way to make it much worse. Put it at a 45-degree angle. Oh, actually, what let's see. So if you're there, then no, we want you. Okay, at any non I guess just under rotation. Because I've never found any problem with like other arcs under rotation. It's just these boundary ones. All right, we have that. And then elliptic arc, but let's see, so elliptic arc. Okay, so you're returning the same kinds of curves. However, in this case, I do have an end A and end B, but I don't use them right now. Okay, we're going to need that elsewhere for our new version. We don't actually need it here. Gee, so this might actually be untested. Oh, do you need like angle of? Nobody needs angle of. I would kind of like to have some of this nasty stuff be abstracted, but getting that from lists is kind of ugly, so probably I have to have these produce a more structured representation. Ellipse point from, okay, that works out the same. What are you? Now Q2, Q1, Q2, P2. I guess you're not really ellipse points anymore, are you? And what the heck are you doing? Oh, you're a singular segment, aren't you? Now that's boundary. We were trying to open up this elliptic arc from angles. It is indeed just that. This must be elliptic angles. Oh, are we doing the same? No, this is actually able to do the path directly. Which makes it a shape. Oh, you know, you're technically a list of shapes. So this is going to add a lot of stuff in diagnosis. So is that wrong, or did that just not render? I feel like this line is bonkers. It looks like we either flipped or overflipped or underflipped something. Okay, well, we didn't do that one for one. That's better. That's not better. That was interesting. All right, display God. So I think that's roughly equivalent. Actually, one thing I wanted to look into was, can we simply draw these darker instead of having to overdraw them? All right, are we missing any major steps from our top level thing here? So duo connectors, gods, basic connectors, basic boons, duo boons. What the heck was that? Let's see. Width divided by 2. Width divided by 2. I was giving you a size, wasn't I? Hey, hit detection even works. The discrepancy in 0 is a little mildly disturbing. I wonder if I feel like it's the alignment of this thing is throwing off that point. It's like, why isn't our zoom working here? Oh, because I'm over this thing itself. So technically I should align that differently to not be quite so far off. We're in view. So I guess you need to line top as well. Okay, that overlaps a little bit better. It's like the top corner of that is the point versus the center of the circle. Well, I guess it's a pretty good breaking point. The boundary rotation mystery, that could be hours of investigation. I'm kind of done with some of this stuff, I think. Unless I want to refactor that some more. Or these should just be all together. And our canvas still also has an origin point in it. Okay, that was not the circle I was thinking of. Okay, let's that is, well, yeah, we're done for now. That is when I'm usually on. Sometimes it's in the evening, but Monday and Saturday are like the scheduled code times. Let's see. Do I have anything else interesting on? Meanwhile, thanks for watching. Thanks for the support from all the subs. Well, I see some people starting up with an initial Godot game.
Yeah.
So I have noticed some. Well, last time I was there, they had music, which is always my favorite thing, and there's also some swearing if you mind that. So if you do, be advised. Otherwise, if you're someplace cool to hang out, Token Wig is someplace cool to hang out. Thanks for hanging out with me. Goodbye, and until next time.